looking at compounding more and more often, our discussion right at the end last time was, does it lead to more and more money at the end of 1 year all the time? And I left you to investigate using the calculator. Maybe some of you did it. Maybe some of you didn't. Okay, so we were using sort of compound interest formula or set up an exponential function. We were doing 1, which we don't really need there. 1 plus whatever the interest rate, which we did was 100%, so 1, divided by x, the number of compoundings, to the power of x, the number of compoundings. It's for 1 year, so it's not x times 1, right? If it was 2 years, it would be to the power of 2x, but we're going to leave it as to the power of x. So really, we don't even need this at the beginning here, so let's get rid of that. We want to look at a table here. I'm going to set up the table with ask, so I can put my own numbers in. I know I probably did this for you last time. There's some numbers that we was using in another class. Okay, so if you recall, if you compound once per year annually, and you're getting 100% interest, and you do it for 1 year, you get $2, right? You start with $1, you get $2. If you compound twice per year, you have a little bit more at the end. Again, it's probably important to understand why when you compound more often, you get that extra 25 cents. For that, you can think about it. We need some space here. Think about each case. If you're compounding annually, you start with $1. A whole year goes by, and we were doing, again, 100% interest. So at the end of the whole year, it goes up here. Now it's $2 if you had a graph of the thing, right? Actually, like that. If you do it semi-annually, you start with $1 here, but halfway through the year, it's going to jump up to, you get 50% each half year. Annually, you get 100% every year, but semi-annually, you get 50% each half year. So they calculate the interest more often. After 1 year, you get 50%, so you're going to go up to $1.50 here, right? This is $1.50. Another half year goes by, and what does it jump up to now? Because you get 50% of this now, not 50% of the original. You get 50% of that, you get 75 cents, so you're going to have in total $2.25, right? So the extra 25 cents is the interest you earn off the interest you got from the first part of the year. When you compound things more often, as soon as you add money, it earns interest. So if you take this to extreme, if you compound more and more, you compound more often here, you get more money. Does that continue to happen if you compound more and more often? If you changed it to monthly, that's what we're looking at here, or weekly, or daily. Not that anyone's going to do that. 4 times per year is called quarterly. 6 times per year, I suppose, would be called bi-monthly. 12 times, of course, would be monthly. It's going up each time. You're getting more and more money, and the reason is because you get interest off interest more often. Every half month would be called, what would it be called? Every half month, 24 times per year? Bi-weekly would actually be slightly different than that. It'd be 26 times per year. 24 would be called semi-monthly. Some of you get paid, probably most of you get paid bi-weekly, right? Every 2 weeks on Friday or something like that. Every 2 weeks you get 26 paychecks in a year. Some jobs you'd be paid semi-monthly, so you wouldn't get paid every 2 weeks. It'd be approximately every 2 weeks, but it'd be on the 15th and the end of the month, so you'd only get 24 paychecks. If you continue this on here, let's, I can't scroll down, but we'll just erase the last one. 52, what's happening with that last number there? If we did it daily, 365, 2.71. If we did it every 365 times 24 hours every hour, 2.7181. It's rounding it off there because it doesn't have enough room, but you can look at those decimals there. If we did it every minute, 365 times 24 times 60. What's happening with this number? Is it continuing to go up? Just a tiny little bit every time, right? it goes up pretty dramatically from 1 to 2. It goes up less from 2 to 4. I mean, I'm jumping quite a bit here. If I increase x1 at the beginning, I get a huge amount more. You're getting less of a difference every time here. I mean, I went from 365 up to 525,000 here, and there's a very small difference. The more you go up here, the less of a difference it makes. There is an upper limit to how much you can get. If you put in huge number here, I don't know, let's do 365 times 24 times 60 times 60. What is that, every second? Okay, it's still to that accuracy is the same. This is going to start changing lower and lower here. The calculator, if you go high enough, because the next thing you would do is probably put in really one with a lot of zeros. Eventually, this has a problem calculating it. The calculator has a difficulty. The reason it has difficulty is look at the original function. At some point, the calculator can't comprehend 1 divided by this huge number anymore. 1 divided by this huge number, at some point, that number, it's too big, and it just rounds that off to 0, like 1 divided by whatever I put in there. Makes that 0, so then it's 1 to this huge power, which is just 1. That doesn't mean it drops back down again. If you looked at the graph, not that the graph necessarily has any meaning, because only the whole numbers mean anything in this situation. But if we looked at 0 to 10 even, or 12, and it's only going to be positive numbers, up to 3 is probably good here. We'll change the scale to 1.